Okay, Assalamualaikum warahmatullahi wabarakatuh. Good day to all students. Okay, today we're going to learn chapter 2, highway capacity analysis. Okay, in this chapter we will cover this following subtopic. First, capacity and level of service, then followed by basic freeway segment and multi-lane highways. So actually the highway capacity is involved many facilities, not only cover this one, but they have also others typical facilities such as a ramp facilities, weaving sections, two-lane highways. But for this course, we are only cover for freeway and multi-lane. Okay, look at this definition for capacity. First, capacity is a maximum hourly rate at which person or vehicle reasonably can be expected to traverse point uniform section on lane or roadway during given period under prevailing road traffic and condition. Okay, the capacity itself to represent how the operation of the traffic flow itself at a capacity or maximum hourly rate can be happen on lane or directions, but consider under normal traffic conditions. Okay, the level of service is a qualitative measure describing operational conditions within a traffic streams and their perception motorists or passengers. Okay, this will be represent as an indicator to look what the condition of traffic flow itself, whether is good or poor. Okay, we can refer this picture. So we have a short of animation to visualize what really condition of this level of service category. So we go for first one. So look at this characteristic of the condition of the traffic flow is very low but high speed. So it's mean quality up to level of service A. Okay, then we compare to level of service B. Okay, it's seem little bit increase in terms of traffic flow, and the speed is less high than this level of service, but still operating at high speed. Next one is level service C. Because the traffic flow slightly increase, the traffic is travel at a reasonable speed. Level of service D, okay, is moving to slightly having much traffic compared to the C. Speed comparable and slightly low than the levels we see. Okay, next we have level of service F. Now we tend to see traffic is heavy and travel speed of the vehicle start going to slow down. Okay, and next level of service F. This considered as near to the congested level, where we see some vehicle is stop and moving and travel very slow speed at this particular lane. Okay, from the A to the F level service, typically we target all the highways should be provide at least several level of service of C or D. Different location might be having good at level service of D, because to make the situation, the traffic is really livable activities. Because some new areas they need to create a flow traffic looking so active. That's mean not bad if you can consider level service of D to represent the road as having busy activities actually, especially for new area, new urban developed area. Okay, multi-lane highway capacity study. Okay, if you look at this uh, detail in terms of the features or factor. Okay, multi-lane highway generally having a posted speed limit of 60 to 90 km per hour. Considered as federal road, up 5, up 4, up 3 as well. Okay, they have already, also 4 or 6 lane, both directions, and often having median or dividers. And some they got a 2-lane right turning lane, two-way right turning lane, which they have one extra lane in the middle, to make a right turn moving, or right turn maneuver. However, they also provide undivided facilities. Some got also this kind of the situation. The multi-lane typically located in suburban community leading to central city along high volume rural corridor connecting to city, or to significant activities generate substantial number of daily traffic. Okay, some example from Batu Pahat to Keluang, so it leading to into central city. Okay, our road classified as multi-lane highway road, as federal road F050. Okay, we can name reference for federal road from Batu Pahat to Keluang as F050. Okay, this is the typical type of a multi-lane highway. So we have this one is divided with the median, separate median, divided highway. This one we have right turning lane, so we have additional lane for turning activities, and we have here a multi-lane for undivided. They not put any divider here, so we have also grade separated, so divided highway, and also at grade, which is they provide some crossing in or in activity in a signalized intersection. Okay, such highway often have a traffic signal that also in F050 Jalan Keluang Batu Pahat. They provide a lot of the signal, traffic signal intersections. So the space is considered at 3 kilometer or less, in the urban street especially. Okay, in terms of the volume of average daily traffics, consider between 15 to 40,000 vehicles a day. In some cases, the volume quite high, up to 100,000 vehicles a day. Okay, this is now the base condition for multi-lane highway. This really a good practice and ideal to provide facilities for multi-lane. The first one is 3.6 in terms of the lane width, 3.6 minimum total lateral clearance. Later I will show what is lateral clearance. Okay, assume as passenger car in traffic streams, no direct access point along the roadways, divided highway, level terrains, driver population mostly familiar with the road users, and free flow speed higher than 100 km per hour, 100 km per hour. So this actually the higher or the ideal condition to provide facility for multi-lane highway. But in reality, sometimes we reduce this typical standard. Sometimes we have a lower budget, or the class road itself need to be considered low grade compared to this higher minimum practice. Okay, these are the lateral clearance, which is consists of width from the shoulder and the median. So lateral clearance, so halangan ataupun sisi, halangan sisi that influence the travel speed of the drivers. Okay, total lateral clearance, which means medium width plus shoulder width. So this is the clearance from this roadway width. So provide more length of or more distance of median will reduce the effect of lateral clearance. But they put the maximum area to be used. So let's say in this particular example, we have 1.6 meter for median, 1.2 meter for shoulder. So total clearance is 2.8 meters. So it note here, shoulder and median is greater than 1.8, use 1.8, and total clearance not more 3.6. Which means some facilities, they provide up to 2 meter until 3 meter in terms of the spacing for distance for divider or median. As well for shoulder, sometimes shoulder got 2.6, 2.5, 3 meter shoulder. But all this distance, consider maximum 1.6 to be calculated in total lateral clearance. So together, they should be maximum at 3.6. That means if you have here 3 meter, this one 2 meter, still we add together at 3.6 meter to be referred. Okay, in terms of access point, some highways for Multilane, they have several access point. This one, the minor in terms of the access or driveway to the our house, and this one consider minor road to enter. This one is the junction or intersection. This one is consider egress or ingress for frontage road or secondary road. Okay, note that each kilometer we have to calculate the number of access point, which means 1 kilometer we have consider how many access point within 1 kilometer. But access point, we concentrate on only active access point. The access road that don't have any activities, sometimes they close, so that particular access will not be counted. Okay, next methodology. Prediction level of service for multi-lane highways involves 3 steps. So simply we have determined the first one is free flow speed. Next, adjustment of volume. Third, determine of level of service. But this one before the so we have to calculate the density. Okay, this is the flowchart or methodology. First, the input from geometric free flow speed or basic free flow speed of volumes. Then we adjusted the basic free flow speed, which affected by lane width, median time, access point, lateral clearance. And from the volume here, we adjusted in terms of PO factor, number of lanes, driver population, and heavy vehicle, percent of value. Then from here, we can calculate free flow speed. Then from here, we can calculate flow rate. So after that, we determine level of service from density. We can refer density to determine level of service. Okay, the first, we concentrate on how to determine free flow speed. Okay, look at here. We have 2 options here. First, field measurement. So if we can measure directly to the field or to the study site, so we consider that is our free flow speed. But this method is rare happen. So we just estimate the free flow speed based on what? First, we can assume from 85 percentile speed from the previous or related data. Okay, if we use 85 percentile speed, also we can also refer to positive speed limit. Okay, let's take a look for this scenario first. 85% speed, we have to lower from this value. Let's say the 85% speed 90, so we can use free flow speed or basic free flow speed at 87 because 90 deduct by 3 km per hour. Okay, if we use 85 style. If we use portal speed limit as reference, okay, there is two condition. If the posted speed limit is between 65 to 70, that can be refer less than 70 or between 85 to 70, not more than 70. So we have to put higher value. Let's say we have 80 posted speed limit, 80 km per hour posted limit. So we have to add more, which is add 11, so 91. If the range of posted speed limit is higher, 80 to 90. Let's say that at that particular area we have 90 km per hour speed limit. So we consider to add 8. Okay, if the post speed limit 70 below, we add 11. But if the posted speed limit higher from 80 to 90 km per hour or 100, 110 refer to expressway, okay, we add 8 km per hour. Okay, here the formula to determine free flow speed refer to this particular parameter. Okay, I'll go back. The parameter first is basic free flow speed, which refer from this one. So this one. If we refer to 85% time, we deduct 3. But if we refer to posted speed limit, we have to add 11 or 8, depend the posted speed limit range. Okay, free flow speed can be determined by first we obtain this one BFFS. Okay, we deduct from factor lane width. You can refer this table, table 2. Then lateral clearance, then medium type, and access point. Okay, we can look at this table. Okay, this one, table 2 is lane width. If we have a lane width 3.0 meter, 3.6 meter, no reduction. We don't have value to reduct because they put as ideal condition. But sometimes they reduce number of the lane width. Let's say 3.3. Then you have to deduct the speed with 3.1 value kilometer per hour. Okay, this one for lateral clearance. So it depends the lane numbers of the highway in both directions. Let's say for lane, you refer this value. This lane, you refer this column. So these are the median type. We have two category median type. If we have undivided, so we have this value 2.6. If the highway is divided, we consider as 0, including if they provided a 2-lane right turn highway. Okay. Okay, next to determine flow rates. From here we have VP, adjustment flow rate VP. We adjust the flow, the original volume. So here we have hourly rate of volume or hourly volume. Okay, vehicle per hours. Then divided by P hour factor. Okay, then number of lane, factor for heavy vehicle, and P driver population. Okay, looking at the P hour factor, P hour factor is the relationship of the which flow higher compared to the total of the traffic volume. Okay, typically for rural and urban area, they recommend this value. Okay, the first one, if not available, we can assume 0.88 for rural, and for suburban 0.92. So we cannot use over this value. The range should be 0.75 and up to 0.95. So we just see this example. Okay, PL factor is relation between hourly volume and maximum rate, flow rate within the hours. Okay, we have here formula. You have to remember this formula. Okay, PL factor equal to volume in hour, volume, total out volume. Okay, and 4 multiplied by V15 maximum. Okay, total volume divided by 4 multiply V15, which is V maximum. Okay, we look at this particular example. Now we have 1 hour, 1 hour data observed for volume. So from 4 to 5 p.m. So in 50 minutes we have this volume. So if you look here, so they already bold, this one. They have higher interval of volume, 1200. So now the total volume is 4300. So to calculate PL factor, simply we just key in, okay, this one is total volume 4200 divided by 4 multiplied by 1200. So we obtain 0.90. Okay, we look again this one. So we select the highest one to put for the P50 maximum. So other example, okay, this quite comprehensive example. They have a movement of the lane, or this one linear intersection. Okay, they observe for 2 hours, but they consider to get for this hours only, which is still 1 hour. So the total volume for this hour from 7:15 to 8:15 is 2307. Okay, if you look at detail for every 15 minutes for this particular hours, so we notice that from 500, 600, 700, and 400 something. So we select 700, which is higher compared to others. So we put here 700 multiplied by 4, the total we calculate already, 2307. So now we obtain at 0.81. Okay, next, this exercise. Okay, try to solve the exercise. Okay, then you will obtain the value. Okay, next, heavy vehicle adjustment factor, FHV. So this consists of character from heavy vehicle, from truck and buses. This one we put under one categories. And also we have next recreational vehicle, RVs. So we can refer that particular table from the previous table. I have shown this table. In this table, okay, here we have category of heavy vehicle factors. Here we have terrain level, rolling and mountainous. Jalan mendatar, jalan beralun dan jalan berbukit. Okay, to calculate factor of heavy vehicles, we have this formula. 1 divided by 1 plus PT is percent for truck and bus, bracket ET that particular tables, this value from this very particular table. Okay, PR for recreational vehicles, that ER value for recreational vehicle. Okay, this one, this value consider as a recreational vehicle. Okay, this value. This one for truck and bus, this one for recreational vehicle. Okay. But in Malaysia, yet we don't have RWL, but we have some numbers, but not many. But in overseas, they have many type of vehicles for RWs, motorhome, like this one, rumah bergerak. Okay, driver population factors. Okay, the stream characteristic basis on mandatorily represent regular drivers, or if the driver familiar with that particular highway, multi-lane facilities, we consider no effect for driver pollution factor. But sometimes we do have non-familiar driver for that particular area, so the value goes range between 0.85 to 1.0. Okay, next step we determine the level of service. Okay, we can measure the free flow speed, then we can know the volume, then from there we can plot into the graph. Okay, then we can determine the density. From this value, we can refer the level of service table. Okay, let's do this some exercise. Okay, determine level of service of multi-lanes highway given FFS is 82.5 km per hour, the speed, profile speed, and the VP, adjustment volume is 926 passenger car per lane per hour per lane. So we calculate per direction. That's why we have having here L and lane, bukan lane, per lane. Okay, to calculate density is VP over S. So here we have 9 to 6 for VP, and S. So S is subject similar to FFS, but they have a typical condition of the criteria. Here, if you refer the table to determine level of service, we have if the 90 kilometer FFS until 120, so we consider, and the VP is less than this value, S equal to FFS. If not, the criteria is not same, or the value of VP is higher than this value, so we consider to use this moderation or this particular correction. But in our example here, we have consider S equal to FFS. So now we calculate the density 11.2. So where to put 11.2? So we need to project. Okay, here we have speed 82.5. So here we can put the value 80. So 82 here, as we just assume here. Okay, the range of volume. So here we have 1000. Here somewhere middle we have 900. So just away from the middle. So we consider 900 to 6. Okay, here we have projection and meet this intercept. So you refer this dotted line. So this line represent the density range. So if the density up from 0 to 7, consider level service A. If density from 7 over 7 until 11, so we'll consider B. So over 11 until 16, C. So over 16 until 22, D. So over 22 until 26 is F. So in our particular case, we have 11.2. So it not easily we can determine B because the value now over 11. So we have to consider level of service C. So we cannot promise to get B because the reality is over than 11. So we should select C. Okay, let's move to this example. Okay, the statement of example. A 1.57 kilometer segment of east-west 5 lane. They have 5 lane, not 4 lane, but they have a conditional. Highway with 2 travel lane each direction separated by 2 lane right turn lane. So actually they have a 4 travel lane, 2 lane per direction, but in the middle they have separated for right turn lane. So given the criteria or characteristic for these facilities for multilane. Okay, rolling terrain. Okay, now we have 85 percentile speed. Okay, please note this one. 85 percentile speed at 83, 3.6 meter lanes. Lane width, 1,500 volumes, 6% truck and bus, 8 access point in westbound. Now, 8 access point in eastbound. So they have different direction with different access point. KPI factor, so you don't have to calculate. They provide that straight value. Okay, the lateral gradient 3.6. So they also provide the lateral clearance. Some question they put the lane width for shoulder and median. You have to calculate that. But this one they give direct 3.6, which is high. So consider no effect for speed reduction. So the question, what is the level of service of the highway on rolling terrain during peak hour? So this question is very straightforward. You have followed this procedure or step to calculate it. Okay, let's move to the solution. So we focus on eastbound first. Cool. Note we to consider this parameter or this characteristic, which direction we're going to analyze. So now we're going to analyze for westbound, eastbound. Eastbound they have this one 6, not 8. Okay, since we have 85 percentile speed at 83 km per hour, we have to deduct. Remember, we have two category to determine estimate free flow speed. If we have 85 percentile, you have to deduct with 3. But if they provide posted speed limit, if lower than 70, you have at 11. If higher than 80, you have at 8. From this particular example, we have to deduct with 3. So we have 80. Okay, from this particular table, we have to determine the factor for lane width, lateral clearance, medium, and access point. Okay, we can refer this table. Okay, first one, lane width. So they provide what lane width? 3.6. Okay, 3.6, 0. So no effect, 0. Okay, now lateral clearance. So in this particular example, they put 3.6. Also, lateral clearance, 3.6. So over 1.8, half of the shoulder. But if you together median and two shoulder, suppose 3.8 divided by 2, so still over 1.8. So in the particular area, we have lane, one lane direction is 2, not 4 or 5. Per direction, we concentrate on eastbound. So 2 lane from eastbound direction. So over 1.8 is 0. So consider 0. Okay, medium type. Okay, medium type. Okay, sorry, medium type. Where the medium type? Lane width, lateral clearance, number of lane per direction, lane width factor. Oh, this one is differ. Wait, I move to this reference. Okay, sorry. Okay, this one. Lateral clearance. Okay, sorry, that one is a wrong reference. That one for freeway segment. Okay, let's back to this one. Lane width 0 table. 0 reduction because we have I want to remove this one. Okay, 3.6 is 0 effect reduction. Okay, next, lane lateral clearance. Okay, lateral clearance 3.6. So we did with 4 lane highway 0. They given the input for lateral clearance here. Okay, 3.6. Okay, median. Median. Okay, here we have median. Okay, undivided highway 2.6. Divided including right turning lane. So in our case, we do have this criteria. Right turning lane, 5 lane, 2 lane for travel, each direction, and 1 lane in the middle for turning lane. So we consider as divided highway including this one. So 0. That's why we have 0 here. So access point. So back to the question. So we have at eastbound. Let's consider eastbound. We have 6 access point. So if you refer your access point 6, so we have 4 here. So we have value of 4 here. So we meet all the value. Okay, now we insert to this formula. So BFFS, don't take this value, but take this value, we have to deduct with 3. So 80 deduct with 0, 0, 0, but for access point we have 4. So now we have 76 km per hour instead of FFS. Now to determine heavy vehicle factors. So in heavy vehicle factor, we have this formula. So because in the question, we don't have info for recreational vehicle. We consider only 6% for truck and bus. So in this particular solution, we have only PT. Don't put PR because we don't have the data. So here we have PT percent of truck and bus. 6% we convert into 0.066%. So don't put 6% here. We consider 0.06. And ET. So how to derive ET? So we back to this table. Okay, equivalent factor for heavy vehicles and RVs. But we don't have RV, we have ET only. The condition of the question, they put in rolling terrain. So 2.5. That's why we have here 2.5. So we insert in this formula the value. Okay, PT 0.06. Don't put 6, but 0.06. 2.5 minus 1. So we obtain 0.9174. So FP consider because they don't give any information regarding driver population factor. So we assume as 1. So assume all the drivers are familiar. Okay, let's to calculate the adjustment volume. So we have here formula for adjustment volume. We have V divided by PFF, number of lane. So multiplied by factor whole vehicle we just calculated previous, and FP. So volume is given 1,500. PFF factor also given 0.9. This one number of lane, not number of total highway facilities for Multilane, but per direction. Remember, we calculate or analyze for eastbound. So only have 2 lane for eastbound and 2 lane for southbound. So we put here 2, not 4 but 2. Okay, this one is vehicle hour factor. No, factor for vehicle. We just calculated before this one. So we have obtained VP. Adjusted volume is 909. So we can calculate curve density. So 909 divided by 76 that we obtained previous, this one. So we obtained 12. So 12, which means at which level of service. Okay, we back to this particular graph. Okay, here. So we have speed at 76. Oh, 76. Okay, if I can use comment section, I think I can use it. Okay, now we have 76 here. Let's just put here. Okay, let's say we have here. Okay, let's put it like that here. Okay, next we have 900. Okay, here, somewhere here. This one is 1000. It's somewhere in middle here. This one. Okay. Okay. Now we have here. The range now is 12. We got the value of density 12. So from this particular normal graph, so we got here, of course, under level of service C. So the value is given 12, consider C, because over 12 up to 16. So we obtain level of service C. Okay, next to calculate westbound. Quite similar, quite similar procedure, but you refer this one. The access point for this side or this direction is 5.3. Where they get 5.3? So here, access point density. So the direction for westbound, they have 8. 6 for eastbound, but in southbound they have westbound they have 8. So here 8. We don't have here a value. You have to interpolate. We have 8 here, so we don't have value here. We put 8. So do the interpolation for this particular range value. So now you can determine here, somewhere here for 8 is 5.3. So now you can solve this function or to obtain FFS, free flow speed. 80 deduct by 0, but we have as a point 5.3. Now we obtain 74.7. Okay, we proceed the calculation. The one is quite similar for the heavy vehicle factor. And the volume also quite similar because number of lane is still 2. Okay, not having extra. So this one also 1 for the operation. But the density is quite different because we have different free flow speed value. This one. Compared to the previous is 80 and 76. Okay, now we have obtained 12.2. So using the similar figures, but in terms of the speed, now they have a different. You can move this one a little bit lower because this one is 74.7. So not right in the middle, but a little bit in the middle. Just 75, but 74. Still region of C. That's why you obtain result for level is C. Okay, that's the procedure to calculate the level of service for multi-lane heavy facilities. Okay, next I have this exercise. So you can try the exercise. A 4-lane undivided, you capture or you just find the key characteristic here. A 4-lane undivided highway on level terrain. Again, we have here level terrain. 3 access point. This one also the characteristic access point, and has 3.3 lane. Lane width. This one is lane width, and the shoulder now we have 1.8. They put specifically. You have to calculate the lateral clearance value. The payout factor 0.8. Okay, the volume is 2,400. Okay, truck and the bus is 6%. So now you have a different value of the truck and bus. What you do? You have to combine. So easily you can put 8%. So that I give some hint. Okay, the section have 70 kilometers per speed. Remember, okay, this one they not supply or they not given 85%, but they given posted speed limit. Remember the step to determine BFFS if they given posted speed limit. Okay, determine level of service. Okay, you will be get this particular answer, but you have to suggest how to improve level of service, how to do it. So I give a keyword. Please look at this value. If you obtain this value greater, so the level of service should be poor or worse. But if you get this value of density less, lesser and lesser, so you will might have good level of service. So that's the keyword to solve that particular question. If you can manipulate this one, you can get a higher value, so you obtain lower density, then level of service might be increased. Okay, the next question. Okay, the second question. Okay, this one is 6 lane divided, rolling terrain, 2 access point, 3.66 meter lane, shoulder now they have 3 meters, left side, but right side 1.8 meter. They have to combine this one and take the maximum value. Okay, as regarding to lateral clearance, okay, payout factor 0.6, 0.9, 0.85. Okay, volume is 3000. Okay, truck and bus 6 to and 2%. You have to combine this one. Now they have different rate or different value proportionate of driver population. So you have to use this one, not one anymore, but 0.9. Now the posted speed limit 100. Say over the 90 kilometer per hour. What should do? Which kind of the category you should moderate or you should calculate BFFS? Say you can determine the level of service to the complete the exercise solution. I think that's all to cover chapter 2 on multi-lane highway capacity. So the next one is freeway segment analysis. Okay, I will continue that lesson. So maybe next time. Okay, until now we finish the chapter 2 specific for multi-lane highway capacity. Okay, that's all for this time, and thank you.